Insurance Solution and Institutions. In this chapter, we will study the nature of insurance, emphasizing the foundation of statistical principle, the law of large numbers, and investigate how the insurance mechanism works. And you're going to review the insurability and types of insurance and insurance companies. The nature of insurance. So you will learn the definition of insurance and how insurance is defined, and law of large numbers, and how insurance works. So we want to analyze the common element of true insurance plan. So insurance plan or arrangement typically include the following element: pooling of losses, payment of fortuitous losses, risk transfer, and indemnification. Pooling or sharing of loss is the essence of insurance. Pooling involves spreading losses incurred by the few over the entire group, so that in that process, average loss is substituted for actual loss. Ideally, there should be a large number of similar but not necessarily identical that are subject to the same peril. Therefore, pooling implies the sharing of loss by the entire group and the prediction of future loss with some accuracy based on the law of large numbers. The primary purpose of pooling or sharing of losses is to reduce the variation in possible outcomes as measured by the standard deviation. For example, two business owners each own an identical storage building valued at $50,000 and assume that there are 10% chance in any year that each building will be destroyed by a peril, and that a loss to either building is an independent event. Then the expected actual loss for each owner is $5,000. And common measure of risk is the standard deviation. The standard deviation for the expected value of the loss is $15,000, as shown here. However, instead of bearing the risk of loss individually, the two owners decide to pool their loss exposure, and each agrees to pay equal share of any loss that might occur. Under this scenario, the expected loss for each owner remains $5,000 as shown here. So the expected loss remains the same. However, the probability of extreme losses, 0 or $50,000, have declined. Therefore, the reduced probability of extreme values is reflected in a lower standard deviation, as shown here. Thus, as additional individuals are added to the pooling arrangement, the standard deviation continues to decline, while the expected value of the loss remains unchanged. The risk reduction is based on the law of large numbers. According to the law of large numbers, the greater the number of exposure, the more closely will the actual result approach the probable result that is expected from an infinite number of exposures. The important point is that with larger samples, we feel more confident in our estimate of future losses. And the risk exposures need to be independent, identically distributed random variables. In other words, we are considering a large number of independent, similar risk exposures that have the same distribution of losses in terms of frequency and severity.